Hello students, so today we are going to start with the periodic classification of elements. So this is the chapter. So remember, what is periodic classification of elements? So classification means to say putting in a group. So this is the classification, but what is periodic? So this will come later on this video. Now let me introduce you about the history of classification. So as you know very well that there were discovery of lots of elements over the period of time, so it was difficult to study the properties of different elements separately. So there was a need to classify, to make a group of these elements as per their similar properties into the groups. So that it will become easy to study the groups of the elements rather to study the different elements separately. So that is why classification, that means making of group of these elements was done. So first of all, the credit goes to this scientist, that is John Wolfgang Dobereiner. So he was the scientist, he was the German scientist. So he has made his first ever attempt to classify these elements on the basis of their properties. Now, if I talk about the Dobereiner, so what he has done, Dobereiner has grouped certain element in a group of three elements with similar chemical properties, and each group he named as triad. So in each group there are three elements with the similar properties, similar chemical properties. Now, what he has also observed, that there was a relation between the properties of the element and their atomic mass. So what he has done now, on in his attempt of making the classification, he has observed that there could be three different groups of triads can be made. So he has made these three triads. One was the alkali metal group, second was the alkaline earth metal groups, and third was the halogen group. Now in these alkali metal group, he has placed these three elements. One was the lithium, then second was the sodium, and third was the potassium. Now there was a common chemical properties in these three elements. First, it was the all three are metals. Then these all three metals are going to react with water to form the alkali. That is why this is the category which is named as alkali metal group. And one more thing is observable in these three elements was that the valency of all three elements is 1. So this was the common, these was the three common property which he has noticed, and that is why he has placed these three elements into the same group, and this group was named as alkali metal group. Similarly, he has made the another group, that is the alkaline earth metal group. So in this he has taken one calcium element, then the strontium, and then the barium. Now these three elements were also having the same characteristics or the property. So these were also metal, and the oxide like calcium oxide, strontium oxide, barium oxide, these are the oxide present in their nature of these elements were alkaline in nature. So and the valency of all three is 2. So these were the common properties which he has noticed, and that is why he has placed these three elements into single group to make this triad of alkaline earth metal. Similarly, the third triad I am talking about is the halogen group. So in this he has taken the metals. In this he has taken the non-metals like chlorine, like bromine, and like iodine. And yes, halogen means to say these are the elements which are going to react with metal to form salt. So this is the characteristic. So all three elements, whether it is chlorine, bromine, iodine, these can react with the metals to form a salt. Like chlorine can react with sodium to form sodium chloride, and same way these two elements, that is non-metal, can react with the metals to form the salts. So this was the common thing. And one more thing, he has observed that all these three elements can react with water to form acid. And if we talk about the valency, so all three elements were having single valency, that is they are monovalent. So these were the three triads which Dobereiner has classified. So seen that there is a common property, I mean there is a relation between the properties of the element and their atomic masses. So how they are related, that let us see in this particular uh, triad, that is alkali metal group. So the relation which he has seen was when these three elements are arranged in order of increasing their atomic mass. For example, lithium, sodium and potassium. So lithium is of atomic mass 7, sodium is of 23 and potassium is of 39. So when these three triads are arranged in their increasing atomic mass, so all three triads, even in the previous slide also, all three were in the same order, like increasing of their atomic mass. So what he has observed, that if we are going to take the arithmetic mean of first and third element of their masses, I am talking about, so lithium is 7 and potassium is 39. So by taking the arithmetic mean of these two atomic masses, so the value which will come will be almost equal to the atomic mass of the middle element. So this way he has seen there was some relation uh, between the atomic masses of these three elements, that is the triad. Same in the case of other triads also, like in the case of calcium, strontium and protium. If we are going to take the mean of these two atomic masses, that is 40 plus 137, if I am going to take the mean, so the value which is going to come will be equal to the atomic mass of the strontium. So this was his observation. And yes, strontium, if we are going to do, it will be coming out around 88.5, and which is equal to the atomic mass of strontium. So this is about the second triad, that is alkaline earth metal group. Now in the case of third triad also, like halogen, so he has seen that same thing is repeating over here, that is chlorine 35.5 plus iodine, that is the third element 127. So adding these two value and getting the average of it, so it is going to come out near to the 80. It will come 81.2, which is near to the bromine, that is 80 atomic mass. So this was about the halogen group. Now this is the thing. Now there was some limitation of Dobereiner classification. One thing is that he was failed to arrange all the elements which were known that time in the form of triads. Only few triads he was able to form depending upon their chemical property. So this was his limitation about the Dobereiner classification, but the attempt was very good, so that it has initiated this way of classification. Similarly, so this was done in the year 1817, remember. So this attempt was made by him in the year 1817. Later on, the new scientist, one more scientist was there, and he has also done the classification, and the classification is known as Newland's law of octaves. So the scientist was Newland. So Newland, his full name was John Newland. So he has formulated one of the law, that is law of octave, which is famous as Newland's law of octave. So this law he has given in the year 1866, and according to this his observation, so when he arranged element in order of increasing atomic masses, and what he has found, that the properties of every eighth element are similar to the property of the first element. So this is the kind of observation he has made when he has placed all these elements in order of their increasing atomic masses. So this was his observation, and this observation was just like the repetition of eighth note in the octave of music. So in the Casios, like in keyboard or in harmonium, So the eighth note, you can see in this slide also, is repeated, like it is the repetition of the first note. Okay, so same way he has noticed that the properties of the elements which he has placed in the order of increasing of their atomic masses. So eighth element is having the same property as of the first element. So that is why he has mentioned this law as Newland's law of octave, or law of octaves, given by Newland. So what is this law is, when elements are arranged in the order of increasing atomic masses, the properties of the eighth element are a repetition of the properties of the first element. So this was the table, as you can see in this slide. So in this table you can see the vertical columns like this. So this is the one group vertical column, this is 2, 3, 4. So you can see there are 7 group in this particular table, and in each horizontal row 7 elements are placed: hydrogen, lithium, beryllium. So this was the table made by the Newland onto the basis of his law, that is law of octave. So you can see onto the top sides these notes, musical notes are present, like sa, re, ga, ma, pa, dha, ni, same way, and these elements are also placed in this 7 vertical columns. Now the observation which he has made, so you can see one more important point, that he has not considered the noble gas in this, like there is no neon, argon, krypton like gases, because that time it was not discovered. So only these elements were discovered, and moreover he has able to place these elements into these particular table which you can see. Now, if we consider the first element, for example, if it is lithium, so the eighth element, so lithium is, let's say it is first element. So if you are going to go right side, so this is first element, 1, 2, 3, 4, 5, 6, 7, 8. So eighth element will be the sodium. So lithium and sodium, so sodium is the eighth element. So sodium and lithium will be, they are having the same property which he has seen in this particular classification. Same way, if we take sodium as first element, so the eighth element will be potassium. So sodium 1, 2, 3, 4, 5, 6, 7, 8. So potassium is the eighth element. So this way potassium, lithium and sodium, all three elements are placed in single group with the same property. So this is the observation made by Newland. And remember, same these three elements were actually taken by the Dobereiner also in his first triad, that is alkali metal triad. Now if you can consider the first element like beryllium, so the eighth element will be magnesium. And if you consider magnesium as the first element, so the eighth element will be calcium. And all three elements are having same property. Okay, so these are the observation made by the Newland while classifying these elements in this particular order. Okay, now there are some limitations also about this law of octave, which we are also going to do right now. So the first limitation was, as you can see, this law of octave was applicable to the elements up to the calcium position. So after the calcium, you cannot say this kind of rules of law of octave is applicable. So this was the first limitation of the law of octave. And yes, the main thing about the Newland was he has only assumed 56 element he has taken under consideration. But what about the elements which are going to discover later on? Because he has not given any space for this. So up to according to him, up to 56 element will be discovered, and there will be no chance. Like he has not given any kind of chance of that these new elements could be discovered later on. है ना? So he has not given any kind of space or facility so that the new elements can be placed or accommodated in this type of law. Okay, so this was his second limitation. And then cobalt and nickel. So as you can see, this is the group of fluorine and chlorine, है ना? And bromine also. In these group, all the elements are halogens. So from where this cobalt and nickels are placed in this particular group. So this was his third limitation. And if we are going to consider the iron, so iron is placed in the seventh group, and cobalt and nickel with same property of iron are placed in first group. So they are very much far away from each other. Iron is so away in the seventh group, and cobalt and nickel are in the first group. So why these have been placed in the separate group? So this was one of the limitation of the law of octave. So this is all about the law of octave, Newland law of octave, and the first attempt, that is the Dobereiner triads. So now we are going to discuss about the periodic table. So one periodic table which we are going to study is the Mendeleev's periodic table. He was a Russian scientist, so he has designed the periodic table in his own way. And second, the latest advanced one which we are going to which we are obviously studying right now is the modern periodic table. So these two periodic tables we are going to study now. Periodic table, let me tell you exactly, it is a chart of element. So you can see all the 118 elements are placed in this chart. And yes, this is the chart which is prepared in such a way that the elements having same property, similar property, so they are going to fall in a same column, vertical column, that is known as group. So we will study how many groups are there and how many periods are there. So horizontal row are known as period, whereas the vertical columns are known as groups, so which we are going to study later on. So remember, in this periodic table, the term periodic means to say, why it is called periodic. So periodic means to say repeat after certain interval. So same way in this also it is periodic, because the elements with similar properties, they are repeated after certain interval or certain period. That is why it is periodic table. So remember, and table means to say it is having vertical rows and horizontal rows and vertical column. So horizontal rows of elements are known as period, as you can see, and the vertical columns of the elements are called as group. So this is the periodic table. So two periodic table we are going to study is, one is Mendeleev's periodic table and second the modern periodic table. And yes, we will also see that Mendeleev has given the priority to the atomic masses while making this periodic table, whereas in the modern periodic table this was the change. In here we consider atomic number as the periodic function, whereas here the periodic function is the mass, atomic mass of the element. So this is what we are going to study in the next class. Okay, so till then you can revise these two topics, that is Dobereiner triads and the Newland's law of octave. Thank you.